Hello, Uli Möller here again from the Automatica.
Hi, Akil Doka, NVIDIA Product Marketing.
So what can we see here at the AGILOX booth?
Yeah, so AGILOX is a NVIDIA Inception partner, and they're building AMRs, or autonomous mobile robots. And one of the things that they're doing with our technology is integrating into their development pipeline. So they're using Isaac Sim, which is our reference robotic simulation application, to really simulate the movement of the AMR. These AMRs are deployed in factories and warehouses, so it's a very complex, dynamic environment. There are humans, there's payloads, there's boxes. So in order to ensure that this AMR can be fully autonomous, they're using simulation to figure out and really make sure that it can run through any type of what-if scenario. And that's really the power of simulation.
Yes, and the environment is changing very quickly.
Correct, yeah.
So you need a good simulation at the end of the day?
Yeah, so it actually starts with building the 3D replica of the warehouse or the factory, down to essentially the kind of detail that you'd want in real life. So we were talking like a real digital twin.
Okay.
And then you can deploy this robot in there and then simulate its movement. And essentially what we're doing is we're looking at the sensor simulation from the robot. So if you have LiDAR or camera sensors, we can, within Isaac Sim, they can actually see what the sensors see and then figure out, okay, you know what, there's going to be an obstacle, I need to stop. Or if there's an obstacle, I need to turn right. So you can simulate all these what-if scenarios before you actually deploy the robot in real life.
So you come to a better type of robot at the end of the day?
Essentially, we want this to be fully autonomous. And in order for you to be autonomous, you have to train it and simulate it across a variety of cases where in the real world, you could never do.
Exactly.
Right? And it could be dangerous, it could be risky. And so simulation allows AGILOX to then figure out how best they can train their robot or simulate their robot before they deploy in real life. So all the different edge cases that you will never be able to do in real life, you can do so in simulation.
And also, which place is the best place to put the sensors?
That's correct, yeah. How many sensors do I need? Where should they be? What type of sensors? And how's that perception model working? All that can be done in simulation.
Yes, and AGILOX had something like an USP. They don't use the safety LiDAR only for the navigation. They have also a top LiDAR.
Yeah, so it really depends on what they really want as part of their design. So again, because of simulation, they can decide if they want LiDAR on top, they want camera on top, and so all the different things they can work through within their development pipeline.
Okay, sounds really cool. I like the AGILOX mobile robotics.
Yeah.
So let's take a look at the next solution.
Let's do it. Yep.